My name is Sam Shames, and I'm going to be telling you guys today about my materials processing video project. So, although you may not know it, one area where materials processing is used extensively is in the commercial food industry. And really any industrial scale or even restaurant scale food operation needs to know a lot of heat transfer processing. So today what we're going to do is we're going to use heat transfer to analyze the deep frying of chicken nuggets. So here's some chicken nuggets, here's a deep fryer. What we really want to know is how many nuggets, how long does it take to cook nuggets, and then how does that tell us about our throughput, so how many nuggets we can cook per unit time. So let's look at our problem statement. That's really what I just said, and it's going to depend on two things, both how long it takes to cook a single nugget, which is what we'll get with heat transfer, and then also how many nuggets can be cooked at a time. So what we really need to think about in this problem is, what exactly is being cooked and how it's being cooked. So we need to think about our chicken and our oil. We're going to be using peanut oil, which is because it has a high smoke point and is neutral in flavor. We're cooking the nuggets to 165 Fahrenheit in 375 degree oil. We're modeling them as cylinders, and then using the internet and actually published papers, I found these properties on both chicken and peanut oil. So that's kind of everything we're going to need to solve this problem. So the first thing we want to do is think about our geometry and our boundary conditions. So we have cylindrical geometry with heat transfer in the R and Z directions, and we have the boundary conditions is convective heat transfer at the surface, so that's constant heat flux, and then we also have this symmetry condition which says at the origin of both the radial and the Z direction there's no temperature gradients. Alright, so now if we think about our governing equation, the first thing we want to do is calculate the Biot number, which we do for each of these, and we see that both convection and conduction are important. We have our governing equation as well, which is the heat transfer equation in cylindrical coordinates in 2D with those boundary conditions that we talked about earlier. So let's watch a little video of some deep frying in action, and we see, so the oil is moving pretty well, so it's, at least agitated, so we had a relatively high Biot number. You have its deep frying. That's kind of, this is what it looks like. Alright, so let's talk about how we actually solve it. So the way we're going to solve it is with superposition and with graphs. So our chicken nugget is a superposition of an infinite cylinder and an infinite plate. So we can use superposition to find the temperatures of each of those coordinates and then multiply them together to get the total temperature of our nugget. So the first thing we need to do, though, is to figure out what dimensionless theta value we actually want to cook our nuggets to. So I have that down here, and it's 0.61. So that's that. So the way we're actually going to solve superposition is we're going to use graphs like this and like this. And what we do is we pick a phone number, and then we find the Biot number that corresponds to that phone number, and then we read off a dimensionless temperature. And you do that for both the plate and the cylinder, being sure to make sure that the phone number used for the plate, you convert it to a time, so then you get the same phone number, you use that time to find the phone number for your cylinder, because they're not going to be the same. And then you read off these dimensionless temperatures and you multiply them together. So you kind of get like a guess and check type method. So here I picked one phone number for the plate, I use that to find the time it takes to cook that, find the equivalent phone number for my radial coordinates, and then I get theta, and after 3 guesses I found that 28 seconds, or a phone number of 0.16, gives you the perfect theta value for the chicken nuggets to cook. So now we know how long they're going to cook, and let's watch this video of nuggets being finished. So, our nuggets have been in there. This is obviously a much smaller deep fryer than the commercial one, but you see those are some good looking chicken nuggets. Alright, so now let's talk about the throughput. So in that small video we just saw, the basket was really small, so you really couldn't fit that many nuggets in. But in the other video you had a very large basket, so you could probably fit a lot of nuggets in. But the thing to consider is the more nuggets you add, the more heat they're going to need to absorb to cook, and they're going to lower the temperature of the oil. And you don't want that to happen because it means the nuggets will take longer to cook and they'll become greasy. And the way we can solve that is by making sure that we're adding heat to the oil at the same rate the nuggets remove it. So the first thing we want to do is calculate what is the rate at which nuggets remove heat. And we can get that by calculating the total number of heat a nugget absorbs to cook, just using like a Q equals MC delta T, multiplying it by the number of nuggets in a batch, and then dividing it by the time to cook. So you have this sort of nugget heat flux, which is right down here. And then what you do is you set that equal to the maximum heat rate that you can add to the oil, which is from the manufacturer's instructions. And from that you solve the maximum number of nuggets you can have in one batch without having the temperature of your oil drop. And so when you do that, you get about 75. And so what does that tell you? That says that if you can cook 75 nuggets in a batch that takes 26 to 28 seconds, then you can sell 2,000 nuggets in a day and cook them in only 27 batches and have it take about 13 minutes. So really what that says is that it's nuggets is that you can have it one deep fryer and use it for chicken nuggets, cooking oil, cooking other things, onion rings. That your deep fryer, things are not going to take that long to cook, so you really only ever need one piece of equipment. So we've learned a little bit about chicken nuggets and about deep frying.